Starting from UniFi Network Application 856, NetFlow is supported, but your UniFi gateway's firmware version need to be higher or equal to 4.1. So there are two version requirements here. End-to-end NetFlow process can be simplified as, okay, you have flow exporter. In our case, UniFi gateway. Then you export the flows to a collector. Then the collector can store the flow records. Then later you can use analytic applications to analyze the data. NetFlow was introduced by Cisco almost 30 years ago. By analyzing the data of NetFlow, you can do troubleshootings, for example, the source and the destination of the traffic, the class of service, and the causes of congestions. There have been totally 10 versions for NetFlow. Version 5, 9, and 10 are significant. That's why you can see they are highlighted in UniFi Gateway's NetFlow settings. The version 5 is the most common version. Version 9 is template based. Later we will discuss what's template, how to define the template when you work on the collector. Then for version 10, the latest one, is used for IP fix. Even though IP fix is heavily based on NetFlow, version 10 does not have anything to do with NetFlow already. So in this video, I am going to only choose version 9 in my testing. There will be 3 parts in this video. First, let's see how NetFlow works in action in my lab environment. Then we will look into the UniFi gateway side to go into the system to see how NetFlow exporter is even configured and supported. Then the third part is we will choose a free open source NetFlow collector, the NetFlow accounting daemon, to see how we can customize a template, customize the aggregation, and to make the storage possible. We will not talk about the analysis application because in my opinion, it's simply some type of general analytics based on database. It's not really so related to networking. Okay, let's see how it works in action. In the right side, I have 2 network controllers for 2 different UDM pros. These 2 sites are being connected using side-to-side VPN. As you can see, I go to settings, system, under integrations. The first option is for NetFlow. Once you enable it, you can choose the subnets managed by that particular UniFi gateway. For my case, for each gateway, I choose one example VLAN. When it comes to versions, just for demo purpose, I pick version 9. If you choose version 10, the flow structures may be slightly different. Version 9 is template based. That's what I want. This is an important part, the collector address. So in the left side, once we configured the NetFlow in UniFi gateways, I will run the collector. For now, let me show you the IP address for the left side machine. You can see this is the .255.44. It is a Linux virtual machine running in the VLAN 255 managed by the first UDM Pro. By the way, in the right side, for the second UDM Pro, you can see the collector has the exact same address. I can do that because the 2 sites are connected using side-to-side VPN already. So the second UDM Pro is also able to access this Linux virtual machine in the first site. Okay, then when it comes to port, I just accept the default one, 2055. These 2 settings, timeout rate and refresh rate, they are both related to how often the system will send the collector the templates. Just some background. The exporter, in our case, the UniFi gateway, can decide the flow record structure. Because it's flexible, there should be a way for the exporter to notify the collector what's the structure, the metadata about the flow record, right? So template is for that purpose. These two settings, the two rates settings, they just control how frequently the templates are sent. I simply randomly change the first UDM Pro, but I leave them default for the second UDM Pro. So then the remaining settings are related to sampling. If you have a lot of flows, you have a super busy network, to send all the flow information to the collector may add burdens to the gateway itself. If that's the case, you may choose sampling. You have different ways to determine how to do the sampling. But in my case, it's just a demo, so I don't have a lot of network traffic, so I simply choose sampling off. Okay, so as you can see, for both UDM Pros, NetFlow settings are enabled already. Then in the left side, let me run the collector. In this video, I choose the free NetFlow accounting daemon. Let me start it. In the third part of the video, I will explain how to configure the template. Now let me simply run it. So you can see here, it says it's NetFlow version 9 because we set the agent, the exporter in UDM Pro to version 9, right? And here it indicates the IP address. For this case, is for the first UDM Pro. By the way, this is a collector, which means it can collect from multiple exporters. So in this video, I'm using 2 exporters. And see, this information is like a table structure. This is the flow structure. It's a template. We will talk about the details in the third part of the video, but you can see what detailed information is included in the UniFi's flow record. And then from time to time, you will see this type of information. The collector received some NetFlow packets. For this case, it's from the second UDM Pro. Now let's see what kind of flow will be captured and what the captured state look like. In the right side terminal, I have a VLAN 66 client. In the left side, let me start from scratch, relaunch the flow collector. Okay, restart it. And then in a separate process in the same collector machine, let me display the update about the captured file. Okay, you can see there are already some flows captured, but they have nothing to do with our testing activity because I haven't started anything in the right side yet. Then let me start something. In VLAN 66 machine, let me use the UniFi gateway, but for the VLAN 255, let me use that IP address as the DNS server and try to resolve ix.com. Okay, it was successful. Then in the left side, let's see whether the flow will be captured. You can see here it's already captured. So what it is saying is this VLAN 66 machine reach out to this VLAN 255 gateway and the protocol type 17, meaning UDP, from this port number to this port number. See, this port number is for DNS, right? The target port number. That makes sense because we are trying to resolve a domain name. And see, the packet count is 1 because we only dig once. Then this is the size of the packet. Okay, apparently for the dig command, yes, it's captured. Then let me still use dig, but use a different DNS server. For example, let me use the VLAN 66 gateway. Remember, this client is in VLAN 66, right? So now it's trying to use its own gateway's IP address, try to resolve x.com. It was successful, right? But let's see this time whether the flow will be captured. I have waited for long enough, but the flow still doesn't show up. The reason is, in the right side, we are doing some intra-VLAN within the same VLAN communication. It won't be captured. We just tried dig, which is using UDP, right? Then let me try something, let's say ping. So let me ping, let's say 9999. Okay, you can see the ping is going on, but in left side, nothing's captured. But if in the right side, if I stop the ping, let's see what's the effect. Okay, you see the traffic, right? From this client machine to 9999, and the protocol is 1. 1 means ICMP, and the packet count is 18. See the right side, we killed it after the 18th try, right? So the count match, and this is the size. The flow is only captured after I kill the ping. Here it comes the concept of flow. Keep in mind the NetFlow is not the same as what you capture, let's say using Wireshark. For Wireshark, it's capturing the network traffic packet by packet, but the NetFlow is showing you the flow information. If the right side ping hasn't been completed or killed, the flow is not finished, so it won't be captured. So let's validate it again. From the right side terminal, let me still ping 9999, but this time let me control the count, ping it only 3 times. Okay, see the left side, the ping information is shown here, and see the count 3, right? Because we controlled it, we only pinged 3 times. This is how the NetFlow is captured. Depending on the nature of the flow, depending on whether it's routed or not, you may observe different behavior. Now is the time to discuss what a NetFlow is at all. If you think of NetFlow as a database table, each record needs to have its own keys to uniquely identify it. In the original Cisco's definition about NetFlow, it has these pieces of information to uniquely identify a flow. They include ingress interface, source IP, destination IP, IP protocol number such as UDP, TCP, ICMP, and then of course you need source part, destination part, and the last one is type of service. If you are interested, you can read this Wikipedia article about what is type of service. So these 7 keys are part of the original Cisco's definition. But you know, here we are talking about Ubiquiti's routers. It is using Linux as operating system. In Linux world, the NetFlow is simply a module within the IP tables. Linux has its own definition about the flow keys. It included this list of fields. If you compare to the original Cisco's definition, you can see it's almost identical. So I won't go through them, but this key definition explains why and how the system will aggregate different network frames into different net flows, because they can be distinguished using these keys. Okay, we tried UDP, which is DNS resolving. We tried ping, which is ICMP. In the right side, let me try HTTP protocol. Okay, it got some data back from the VLAN 255 server. Let's see whether the HTTP traffic will be captured. Okay, so it's from this VLAN 66 client machine with the VLAN 255 HTTP server, and the protocol number is 6. 6 means TCP, and then totally 6 frames. Okay, so now you see the effect of TCP, right? I think that's enough just to see NetFlow works in action. Let's move on to the second part of the video. Try to understand how NetFlow is implemented within UniFi gateway. In this Linux terminal, let me SSH into UDM Pro. Okay, I know NetFlow is using port number 2055. Let me run netstat command. Okay. There's only one line returned. Let me explain what it means. So what it is saying is, from this UniFi gateway's IP address, more specifically from VLAN 255, there is a process which is connected with this IP address, with this part. This part is NetFlow, right? What's this IP address? This is our flow collector's IP address. It is also configured in the UniFi gateway. We configured it here. We are clear about this part, and this part is about the UniFi gateway itself. And see the process name is dash. Dash means it's part of the Linux kernel. To understand what module from kernel is for NetFlow, let me run another command. This is just a regular way to list the Linux kernel modules. I just want to see the NetFlow related ones. Strangely, it doesn't return anything, but maybe that's related to case of the letters. So let me use parameter I to ignore cases. Okay, so the module name is IPT NetFlow. If you search internet, this is the source code for IPT NetFlow. It's open source, it's free, and it's part of the Linux kernel. Okay, go back to our SSH. Then we can see how it is configured. Let me use syscontrol command. Okay, see all these parameters, they are just reflecting whatever we set on the UniFi network controller. For example, the timeout rate, the refresh rate, and the NetFlow version is version 9 as we configured, and the destination, the NetFlow collector we are running. This is how what we configured on the user interface is implemented in backend just by using NetFlow kernel module. And if you want to see the NetFlow statistics, you can use this command to display the runtime information in real time. Okay, you may see some interesting details here, protocol version 9 or the configuration parameters, and you can see just by enabling NetFlow what's the system resources you use for each CPU, how it will impact the CPU utilization, and how many packets are captured. By the way, by enabling NetFlow, if you are too aggressive trying to capture a lot of information, it may impact the performance of your UniFi gateway. Just be aware of that. Now we see the Linux kernel, right? But it still doesn't explain how the system will do something when it receives a packet, how it will do something accordingly based on the NetFlow setting, right? It's time to dig into IP tables. Remember, I mentioned in Linux, NetFlow is simply part of the IP tables. So let me use IP tables command. Let me use the filter table, the default table, display the detailed information. There are a lot of rules, including all of your firewall rules. But what we are interested in is NetFlow related rules. They are all here. We have the NetFlow in, out chain. Let's try to understand how this NetFlow related rules are about. It is saying it doesn't matter for all the protocols as long as the in interface is one of the two 1 parts in the network controller, port 9 and port 10. They are 1 part, and here internally is S8 and S9. As long as these two 1 parts, they are the in interface, it doesn't matter what's the out interface, and it doesn't matter what's the source network and the destination. As long as we want to do NetFlow activity, the target will be NetFlow. The target NetFlow means it will go into the kernel module, which is IPT NetFlow. Okay, so let me use the third rule to repeat the logic. It doesn't matter what's the protocol as long as the input interface is the WireGuard interface. Remember, we have the side-to-side VPN, and I am using WireGuard for the side-to-side VPN. That's why it's talking about the WireGuard interface. As long as the input interface is WireGuard interface, it doesn't matter what's the out interface. It doesn't matter what's the source network. As long as we want to do NetFlow, it will go to this target, which is the kernel IPT NetFlow. Okay, but now if you are careful enough, you may already have a big question, because in all the 3 rules here for source, they are all anywhere. But in our NetFlow configuration, we say only for VLAN 255 we want to log the NetFlow, right? Then where is VLAN 255? It's not anywhere in the 3 rules, right? In fact, VLAN 255 is represented somewhere else. So let me scroll up. See this ubiquitous flow accounting chain? It will call the 2 chains we just talked about, the NetFlow in and out, right? But see in what kind of situation it will call these 2 chains. For in chain, only if the input interface is BR255. This is where the VLAN 255 customizing we did on the UI is represented. Still in IP tables, but in another chain. So if you consider consider this chain and the two chains we just talked about. If you think about them together, basically what they are saying is if the traffic is from VLAN 255 and if it will go through the WAN parts or the WireGuard part, the NetFlow will be logged. Or other computers outside of VLAN 255, they want to reach out to VLAN 255 from the two WAN parts or from the WireGuard interface, then the traffic will also be logged as NetFlow. That explains why in some scenarios we won't see NetFlow, in some we will, only because of these IP table rules. Okay, I hope it's clear how the NetFlow works internally. It will explain your future confusions. When you configure NetFlow, expect to see something but it's not captured. You may want to look into the IP tables to understand why or why not a flow is captured. In the third part of the video, let's talk about how to configure a NetFlow collector. In this video, I'm going to use pmacct as an example. This is the web page for pmacct. It's a passive network monitoring tool. It can collect multiple types of data, including NetFlow, V5, V9, and IPFix. It can save data to files to different databases. In this video, just for the simplicity of demo, I'm going to use flat file. Of course, in real world scenario, a database is better choice. In Debian Linux, you can install the pmacct package using the regular Debian way. You can use apt install. The package name is pmacct. Because I already installed it, so that's why it doesn't install anything. Once it's installed, all the configurations are in the etc pmacct folder. So we will talk about the configuration file later. But first, let's talk about primitives. For primitives, you can think it as standard definition of data field type, as in database. Let me show you what I mean, because I already have the pmacct configured. So let me run it, then show you what I mean. So let me start the NetFlow accounting D process using this already created configuration file running in debug mode so that we can see the template information. If you have some network activity, for example, in the right side, let me ping 9999. Okay, kill it. Then see in the left side, let me kill it as well. In the left side, you see this debug information. This is the so-called template. Remember I mentioned we choose version 9 because NetFlow version 9 is template based, right? So this is an example of the template. Because the NetFlow information is dynamic, the sender, the exporter, in our case Ubiquiti gateway, decides what's the structure for the NetFlow information. There must be a way for the exporter to notify the collector what's the structure. Template is the way. So basically it's just like a regular database table definition, right? Let me explain what it means. So PN stands for private enterprise number. In our case, they are all 0, so we can ignore this column. The field type is the thing we want to focus on. This part, the English wording, is just this particular software, pmacct, its own description about the data type. The real crucial thing is the number inside the brackets. So you can see number like 8, 12, 60, right? They are not some customized number. They are predefined. If you want to know what these numbers are, I have the URL listed here. For example, you see 8, 12, 60, right? Let's use them as example. So this is the page for the IPFix entities. So remember I mentioned number 8, right? See what's number 8? It's the source IPv4 address. Then what's 12? Destination IPv4 address. Then let's see what's 60. 60 is IP version. So you can find all the standard definitions in the web page I just showed you. And from the pmacct debug information, you can see for some field, especially for the ones which have values greater than 100, the pmacct cannot correctly recognize them. So it doesn't show what's the English wording, but we can get the definition from the page 256, right? Go back to the page 256. So it's Ethernet type. Because this pmacct software doesn't have the complete field type definition, I don't want to use its default field name. I want to define my own purely based on what Ubiquiti provide in the template. So the way to define them is called primitives. Basically, I want to define what these numbers in brackets, what they mean, what their data types are, just like when you define in a database table. So let me show you the primitives I already defined. So in the right side, let me go to etc pmacct. Then let me show you the primitive file I defined. This simply reflects what we have in the Ubiquiti's template. For example, the first field, I can give it whatever name I like. I say source address and the field type 8, where 8 comes from Ubiquiti's template. And where the longs come from Ubiquiti's template. Where the semantics come from, you need to check the web page I just mentioned and give it proper name. For example, the IP address, of course, semantics IP. And for example, the version, the port number, the semantics is unsigned int. And the destination and the source MAC addresses, the semantics are MAC. So in this way, I define these custom primitives. Once I have this simple file defined, I can go to the real collector configuration to use these primitives. Because remember here, just like how we deal with database, when we deal with the collector, we need to define the structure. So in the left side, let me show you this particular configuration file. NF stands for NetFlow, right? So this is for NetFlow accounting daemons configuration. Okay, you can see it's a very simple customized configuration. It's just my way used in this demo. Of course, you want to change it or you want to customize it to work with your way, right? So the way this configuration file use comments is using the exclamation mark. So all this are just commented out. So starting from this line, you can see I define the port number as 2055. Remember, when we check the backend in the UDM Pro, I used this port number, right? Okay, move on. The plugins simply tell the collector how you want to store the data. As I mentioned for this video, to simplify it, I use file, right? To use file, I simply use the plugin print, which means it will print the string to screen to file. Then the word I put in bracket is just scenario name. So in the whole configuration file, I only have one name. I call it test. You can use whatever word you want. This part is very important. It's called aggregate. You have different ways to aggregate your data. So the word aggregate means, yes, from the UniFi gateway, it tells you the finest granular data structure. But it doesn't mean you have to store the data in this fine way. Maybe you want to aggregate data. For example, if you're only interested in the source IP address, then you can only aggregate data based on source IP address. If you are only interested in the IP protocol number, for example, you only want to see how many ICMP packets, how many TCP packets, or how many UDP packets, you can do the aggregation only based on the L4 protocol number. You have whatever way you want to aggregate data. But for the purpose of this video, remember I talked about the NetFlow keys. I want to store the data in the finest granular way. So that's why here I included all the key fields. These fields come from the right side, the primitive. Now these two configuration files are linked together, right? So based on the right side primitive definition, here I define the aggregate. To put it another way, I define the structure of the table. Then the remaining part is just to control how to write the file. If you want to write data to database, you need to have different setting, right? But for me, I'm simply saying, okay, write the data to this CSV file. The format is CSV, and every 2 seconds, I want data to be flushed, and I want data to be appended to the existing file. To separate different fields, I want to use tab, just for better reading from the screen. And of course, at the end, I define where is the primitive definition for the right side file. So you can see this is a very simple configuration definition. And once you have this configuration file done, you can run it in this way, or you can use system control to enable the service to be started automatically every time the operating system is rebooted, right? You simply say, okay, where is the configuration file? And if you like, you can display the verbose information, the debug information by using -d. That's it. This is just a simple introduction about this free but powerful PM accounting daemon toolset. Okay, this is the end of the video. Thanks for watching.